Okay, here we go. AP Classroom, Unit 5, free response question set B, question 2. No calculator is allowed for this question. All right, background information here. This problem actually starts right here. All right, so we have the number of mosquitoes in a field after a major rainfall is modeled by the function m, defined by m of t equals negative t cubed plus 12t squared plus 144t, where t is the number of days after rainfall ended and goes up to 18 days. So sometimes I think it's helpful to identify that this is the number of mosquitoes and t is days. Okay, so part A, using correct units, interpret the meaning of m prime of 15 equals negative 171 in the context of the problem. So m prime is a rate of change. So this is how fast the number of mosquitoes is changing at time 15. So if we write this out then, part A, it's how fast the number of mosquitoes is changing. Well, it's changing at a negative number. So this means that the number of mosquitoes is decreasing at a rate of 171 mosquitoes per day on day 15. Oops. Okay, and that was, I'm going to do points as we go along in here. Hopefully I remember to do them each time. So that was just +1 for the answer. You had to have the units, and you had to talk about that it was how fast the number of mosquitoes were changing. Okay, part B says, based on the model, what is the absolute maximum number of mosquitoes in the field over the time interval, and then justify your answer. So absolute maximum, anytime we want that, we're going to have to do a derivative. I'm going to need some more space than what's down here, so I'm going to go to another piece of paper. In part B, based on the model, what is the absolute maximum number of mosquitoes in the field over this time interval? So we know that the number of mosquitoes is negative t cubed plus 12t squared plus 144t. To find a maximum, we're going to have to do a derivative. So m prime of t, and this will be a negative 3t squared plus 24t plus 144. I need to know where this is equal to 0, so I'm going to factor this, and let's factor out a negative 3. That'll give me t squared minus 8t minus, 144 divided by 3. 3 goes into 14 4 times, remainder 2. 3 goes into 24 8 times, so this is minus 48. Now we can factor that. Multiplied by negative 48. How about a minus 12 and a plus 4? Okay, so once you have m prime, then we can look where m prime of t is equal to 0, where m prime of t is undefined, or m prime of t does not exist. None here, none here. But m prime of t equal to 0 is going to occur at t is 12 and at t is negative 4. We can take out this negative 4 one because for real life problems like this, time can't be negative. So that's out. We want absolute maximum, so we're going to need to check the endpoints as well. So we have t and m of t, our critical number, 12, and our endpoints, 0 to 18. All right, so m of 12. Oh boy, this is going to be negative 12 cubed plus 12 times 12 squared plus 144 times 12. Oh my goodness. Okay, so you're doing this without a calculator. Oh gosh, this is negative 12 times 12 times 12. This is 12 times 12 times 12. So very nicely, these guys are going to cancel each other out, and all we need then is 144 times 12. 288, 144, 8, 2, 1, 7, 1728. Okay, 0. Oh, that's nice. That's nice. Yay. 0. 18. This is going to be negative 18 cubed plus 12 times 18 squared plus 144 times 18. Oh my gosh. Ick. Gross. Absolute maximum. Okay, so I do not want to do that. Blech. So what I am going to do is think about the shape of this curve. So that curve, that cubic, must have looked like, let's see, cubics, one end up, one end down, and oh, you know what, I don't even want to do these x and y axes here, forget this. So we know one end up, one end down. It has to go like this. This value right here, that must have been the first critical number, so this spot right here is when t equals negative 4. This spot must have occurred when t is 12. So what does that tell me is that t equals 18 is way down here. Is down here, which means that very definitely it is less than t when t equals 12. Which means if I'm looking for an absolute maximum value, it can't be this one at this endpoint. It's not that. It's this one. It's 1728. So the absolute maximum number of mosquitoes is 1728. Okay, point values here. You get 1 point for just identifying, finding m prime of t. So plus 1 to find m prime of t. You're going to get 1 point to recognize that you have to do m prime of t equals 0. You're going to get 1 point for identifying t equals 12. And then 1 point for the answer. That one was kind of rough without a calculator. I was kind of irritated when they gave you numbers like that. That's just nasty. Maybe you would have wanted to multiply that out. Personally, it was easier for me to think about a graph. But however you think about it is perfectly fine. Oh, this was part B here. All right, so part C. Part C says For what values is the rate of change of the number of mosquitoes in the field increasing? So rate of change of the number of mosquitoes. Oh, that's off of a derivative again. So m prime of t, which we found, rate of change of the number, oh wait, rate of change increasing. So when is that rate of change? Rate of change of the number of mosquitoes, that's m prime of t. So when is m prime of t increasing? All right, that's talking about second derivative. So m prime was negative 3t squared plus 24t plus 144. Let's find that second derivative. M double prime of t gives us a negative 6t squared plus 24. You factor negative 6 out. Uh-oh, not negative 6t squared, negative 6t. My mistake. That gives us a t minus 4. So m double prime of t equals 0. M double prime of t undefined, does not exist. None here. And this is going to occur when t is 4. All right, so we want to know when m prime is increasing, so we need to know when m double prime is positive. So let's set up a number line here. 4. And when t is less than 4, say 0, then this is, did I do something wrong? Negative 6. No, I don't think so. So negative here. Something's not right. Hold on, let me think. Something's not right. Put a 0 in here. This is negative. Oh, no, I'm right. Okay, never mind. My brain was not working for a minute. Sorry. Does that happen to you? Okay, so if I put a 0 in, then this becomes negative 4 times a negative 6, which is positive. That, yeah, whatever. Okay, plug something bigger than 4 in, say 5. This is positive times negative. This is negative. All right, that means that when m double prime is positive, then m prime is increasing. So we can say the rate of change of mosquitoes is increasing. All right, what's that interval? No, it's not just strictly less than 4 because our time value was just 0 to 18. So for 0 less than or equal to t less than or equal to 4, because m double prime of t is positive. All right, points here. So it was plus 1 to consider m double prime of t. So if you start talking about, find something with m double prime of t, it was plus 1 to actually find m double prime of t. Excuse me. And then it was plus 1 for the answer. Okay. The last one here, part D, I thought this was tough. It took me a while to figure out what they were looking for here on this part D. I didn't like the question, but there's nothing I can do about that. Okay, so for D here, for t less than or equal to, or t between 0 and 18, the number of bats in the field is modeled by this differential equation B, where B is a function of the number of mosquitoes in the field. Based on the models, write an expression for the rate of change of the number of the bats at time A. So, part D here. The number of bats in the field is modeled by the differential function B. So the number of bats, B, it's a function of the number of mosquitoes. So the number of bats, B, is a function of the number of mosquitoes. That. Okay, so the number of bats, B, is a function of the number of mosquitoes. Write an expression for the rate of change of the number of bats in the field at time A. So the rate of change is going to be a derivative, so we want B prime of M of T times M prime of T. And we want this at some time A, so B prime of M of A times M prime of A. That's the rate of change of number of bats. There we go. It was 1 point for that answer. Now, if you did happen to substitute in the M of A and write it as negative T cubed, negative A cubed plus 12A squared plus 144A, and then figure out what this derivative is, that's fine, but you're good to go right here. Okay, thank you very much. I hope it made sense.